When you're sitting in a splicing van, staring at a dark street cabinet, relying on generic diagnostic tools is a liability. Fiber optic data streams are incredibly fragile. If you try to measure a dense network with inadequate equipment, that central light pulse scatters, and your visibility into the network fails entirely. The first thing you lose is precision. A weak OTDR simply cannot resolve two closely spaced patch panels. The data blurs together into a single, inaccurate reading. The second issue hits when you are shooting down long fiber spans. The power budget drops off, and you are left trying to read messy, complex traces loaded with static and noise. This leads directly to wasted hours standing in freezing conditions and the massive financial drain of unnecessary truck rolls. In telecommunications, buying into broad marketing promises directly translates to failed traces and guaranteed network downtime. The Comway Max 600 OTDR series bypasses marketing fluff. It is a precision-first tool built entirely around exact specifications. What you are looking at is a modern, interface-driven platform. The physical housing weighs just 1 kilogram. It's built to survive drops and dust, specifically so it won't drag your outside plant technicians down in the field. Internally, this single exterior houses 4 vastly different, specialized optical architectures. Your procurement team and lead engineers have a specific job to do. You must match the exact wavelength configuration and dynamic range of the unit to your daily network topology. You are trading your initial capital investment for exact situational readiness. You avoid overspending on features you don't need, while ensuring you have the exact power required when it actually counts. Before we look at the specific modules, there is a baseline level of performance standardized across the entire Max 600 line. This animated graph illustrates the baseline resolution. Every model features an event dead zone of less than 0.8 meters. When a traveling light pulse encounters 2 very closely spaced connectors, the unit clearly registers them as 2 distinct vertical spikes. But seeing the spikes isn't always enough. Technicians rushing to restore service can't waste time interpreting messy waveforms. The Iola link mapping software automatically converts that raw data into readable block-based icons, giving you an instant pass or fail report. Add in a 12-hour continuous battery runtime and a 7-inch sunlight-readable touchscreen, and the physical platform is entirely field-ready. Those shared features solve your environmental pain points. True operational readiness, however, depends entirely on selecting the correct internal optical module. For local network and access technicians, the M1 standard single-mode module is a highly cost-effective daily driver. The parameters are tightly focused. It uses 1310 and 1550 nanometer wavelengths paired with a 32 by 30 decibel dynamic range. It handles standard point-to-point loops up to 100 kilometers perfectly. The limitation is straightforward. The M1 simply lacks the deep power budget required to push through and accurately map splices on extended regional backbone infrastructure. If you are an engineer managing those massive multi-city spans, you require the M2 long-haul powerhouse module. This dual line chart demonstrates signal degradation over distance. While the M1 line drops into static around 100 kilometers, the M2 utilizes its boosted 40 by 38 decibel dynamic range to push the signal significantly further with absolute clarity. The choice comes down to your routes. You gain the power to shoot massive spans with the M2, but you avoid the unnecessary cost of that extra power if your daily work consists entirely of local FTTH drops. Live maintenance teams working on passive optical network architectures face an entirely different set of high-stakes variables. Their strict operational constraint is that they must troubleshoot active lines to find macro bends or breaks without ever disrupting existing customer traffic. The M3 Live Fiber Specialist module is engineered precisely to navigate this bottleneck. It utilizes an out-of-band filtered 1625 nanometer port. This allows your technicians to conduct highly accurate diagnostic tests completely outside the active traffic wavelengths. For live maintenance teams, the M3 is non-negotiable. You are deploying a highly specialized testing capability to guarantee constant customer uptime. Private enterprise data centers, campus backbones, and multi-dwelling units introduce extreme variability into a contractor's schedule. The primary challenge here is the constant need to bounce between short-range internal multi-mode backbones and standard single-mode telco feeds. The M4 quad module was designed to solve this specific crossover challenge. Looking at this diagram, you can see how the M4 bridges the gap. It houses 850 and 1300 nanometer multi-mode wavelengths on one side and standard 1310 and 1550 nanometer single-mode capabilities on the other. They overlap perfectly inside the M4 quad unit. The M4 empowers contractors to seamlessly test and certify any enterprise link they encounter. However, it carries a premium price tag that is entirely unnecessary for a technician working purely on outside plant telecom networks. Equipping your field teams effectively means making your purchasing decisions based strictly on your daily operational bottlenecks and not on broad, generic marketing promises. This flowchart isolates your needs. First, is your network active? If yes, branch directly to the M3 Live Fiber Specialist. If dark, we move down. Do you test multi-mode data centers? If yes, branch over to the M4 Quad Hybrid module. Letting precise topology constraints dictate your procurement requires a bit more upfront effort, but it ensures your teams have the exact range and wavelength they need before they arrive on site. This final datasheet matrix breaks down the entire lineup for your procurement engineers to reference. To summarize, M1 for local access, M2 for regional backbones, M3 for live maintenance, and M4 for enterprise data centers. Stop guessing your traces. Rely on exact specifications to equip your field kits.